Hello everyone, today we are going to discuss the POSIX system calls. The first system call is from process management, the fork system call. This system call, the fork system call creates a new process by duplicating the calling process. The new process is referred as a child process and the calling process is referred as a parent process. This is the syntax for the fork process system call. This returns the PID of child process if the system call is success, and for failure is written -1 to the parent. No child process is created. The second one is a clone. This is the same as a fork system call. This creates a new process in a similar manner to fork system call. This returns the process ID of the child process, and if the failure occurs, then -1 is returned to the parent. The execv, this executes the program pointed to the file name. The file name must be either a binary executable or a script starting with a line of the form. This is the syntax for execv. This does not return any value, but if the failure is done, the -1 is returned. The next one is the exit system call. The function of exit terminates the calling process immediately. Any open file descriptions belong to the process are closed. This is the exit system call. This is the syntax for exit system call, and it does not return any value. The next one is the wait system call. All of the system calls are used to wait for the state changes in a child of the calling process and obtain information about the child whose state has changed. And this is the syntax for wait system call. This returns the process ID of the terminated child process, and on failure -1 is returned. Next one is get PID, the get process ID system call. This is the syntax for get process ID system call. This returns the process ID of the calling process, and another one is get PPID, get parent process ID. This returns the process ID of the parent process. Another one is get TID, that is get thread ID. This is the syntax for get thread ID. This returns the caller's thread ID. In a single threaded process, the thread ID is equal to the process ID. The next is a set UID, set the user ID. This is the syntax for set UID. If this is set to the effective user ID of the calling process. This returns 0 if the success, and returns -1 for failure. Get UID. This is same as a set. This is same as a set UID. This returns the real user ID of the calling process, and there is no failure for this system call. This is the syntax for get UID. This returns a real user ID of the calling process. The next system call is set NS. Given a file descriptor referring to a namespace, reassociate the calling thread with that namespace. This is the syntax for set NS, the set namespace, and for a success 0 is returned. If the failure is occurred, -1 is value is returned. If it is a file descriptor. The scheduling set attribute. This is a system call sets the scheduling policy and associated attributes for the thread whose ID is specified in the PID. This is the syntax for the set attribute system call. This is also returned as 0 if the success, and return -1 if the failure occurs. This is thread PID. This is a pointer for the attribute. The next system call is the scheduling set parameters. This is the syntax for set parameters. This sets the scheduling parameters associated with the scheduling policy for the process identified by PID. If PID is 0, then parameters of the calling process are set. This returns same as set attribute.
BRK system call. It changes the location of the program break, which defines the end of the process data segment. It returns 0 or 1, -1 as values. 0 for success return, and -1 for failure. The next one is mmap. mmap creates a new mapping in virtual address space of the calling process. It returns a success for returning a pointer for mapped data, and failure for -1 if it returns. The next one is mlock. Mlock is a part of all the calling process virtual address space into RAM, preventing that memory from being paged to the swap area. The next one is uselib. Uselib is a system call serves to load a shared library to be used by the calling process. It is given a path name, the address where the load is found in the library itself. The library can have any recognized binary format. The next one is ptrace. Ptrace is a system call provides a means by which one process may observe and control the execution of another process and examine the change these traces memory and registers. It returns a success ptrace by returning the request data. The next one is open. Open system call creates a new open file descriptions an entry in the system wide table of the open files. It returns as a new file descriptor. The next one is fcntl. fcntl performs one of the operations described below on the open file descriptors fd. The operation is determined by cmd. It also returns a new file descriptor on success. The next one is close. Close a file descriptor so that it can no longer refer to any file and may be reused. It returns 0 as a success. The next one is create. It possibly creates a file with the operating systems and opens it if it's not in the system. The next one is mknod. The system called mknod creates a file system node that name the path within the file systems, which attributes are specified by node and a div. The mode argument specifies both the file mode to use and the type of the node that to be created. Next one is chdir. It changes the current working directory of the calling process to the directory specified in path. It returns success for 0 and failure for -1. The next one is link. Link creates a new link, also known as a hard link, to an existing file. If new path exists, it will not be overwritten. The next one is stat. Stat retrieves the information about the file pointed to by the path name. The difference of for fstat is it expects that the path name is a symbolic link, then it returns the information about the link itself, not the file that it refers to. The fstat is identical to stat except that the file which information is to be retrieved is specified by the file descriptor fd. Thank you.